Hello everyone. Today I'm excited to introduce our tool Jim-E for tackling Challenge 1. So our team consists of 6 members, me, Alan, Charlie, Ritik, Alex, Hassan and Jax. So our challenge started with a simple question. How can we use AI to make project risk management faster, smarter and more consistent? You might also be wondering why Jim-E. It stands for Judgment Informed Machine for Evaluation, because we wanted to humanize the technology and make a digital colleague. But in short, Jimmy turns risk data into actionable intelligence, helping project teams identify weak risks early, improve mitigation quality, and predict their potential schedule effects before they happen.
Before we started building Jimmy, we wanted to really understand who we are designing it for and what problems they actually face. The idea behind this value proposition canvas is simple. On the left, we define how Jimmy acts as a pain reliever and gain creator, helping them to do their work faster, smarter, and with more confidence. And on the right, we capture what our users are trying to get done, their daily jobs, challenges, and frustrations. I'm going to focus on one persona, the data scientist. They're responsible for building predictive models, analyzing project data, and validating trends. But in reality, they spend most of their time on low-value tasks. Their biggest pain points are fragmented, inconsistent data, often sitting in SharePoint, spreadsheets, and reports that don't align, time wasted cleaning and labeling risk data before it's even usable, lack of context around the real-world impact of risks and mitigations, making it hard to validate model outputs, and difficulty demonstrating model accuracy and traceability to stakeholders.
So our approach for Jimmy was simple but solid. Clean up the SME approved heuristic survey and training risk register to be fed into the LLM and used as a reference. As part of our future scope, we would see a beta test that includes incorporation of our feedback loop, which would then make Jimmy ready for the next revision. So Jimmy works through 2 current modes of function. Mode 1 is to improve the risk register and mode 2 is to identify weak entries. So risks are entered either through single line entry or multiple line risk registers. Jimmy then suggests improvements based on the operating mode where the user can then agree or disagree. Touching on the last slide, these are logged into a submission database and sent for SME approval in our feedback loop. This is done once a revision cycle and marks the start of a new issue of Jim-E.
Hi, I'll be doing a short demonstration on the user interface for our app called Jim-E. So here we've got a text input where we can manually input a potential risk. You can then analyze this risk where it would give you a potential mitigation. The user can choose to agree or disagree with this. If they choose to disagree, they will need to provide the reason why they disagree. This is then stored in a submission history for tracking changes to our risk list. Next option is to add in an Excel file where you can add in an Excel and it will extract all the risks from this Excel file. The user can then select multiple risks, analyze these multiple risks as we did previously and choose to agree or disagree with this. If they choose to disagree, they would also need to provide reasoning as to why they disagree. Thanks.
In this demo, we are showcasing a retrieval augmented generation framework that enhances our language model with domain knowledge. To run it, simply open the notebook in Google Colab, upload the provided data files, and execute the code. After brief setup of the LLM, you can enter the risk title. The system retrieves up to 10 similar examples and automatically generates a clear data-driven mitigation. You can then continue analyzing more risks or exit the session. Thank you.
So we also trained a ChatGPT based model for the LLM, where if you just input your risk, Jimmy will help recommend ways for improving your risk description. And it's been trained with heuristics data that we've provided. So for example, if you just put the risk there, it will actually spit out some heuristic-based feedback here, and then you also get some improved examples. So this is what runs in the back end, and this is the front end where the users interact. So you can use some example cases here. In this case, where if we choose a test input, for example, the ChatGPT model, so what it does is in the real product, if the user puts this detailed description of the risk, it sends it, and the ChatGPT model sends back the answer here, and you can accept or reject the feedback.
So for our future roadmap, we're looking at a staged rollout. This will include for stage 2 is all about integration, where we look to integrate with industry. And finally, for stage 3, we will seek to deploy Jimmy with a more user-friendly
Jimmy transforms risk management from a subjective exercise into a scalable commercial advantage through reduced project overruns, proactively identifying weak risks and mitigation prevents costly delays and budget breaches, proactive cost control, reduce unexpected overruns through early visibility of the most critical and poorly defined risks, scaled expertise, automating SME judgment allows consistent high-quality risk management across all projects without increasing overhead. Informed decision making provides clear data-driven insight into risk exposure, enabling smarter resource allocation and bid decisions, and unbreakable resilience. Build a self-improving risk system that adapts to new threats, strengthening your competitive advantage.
So the first of the judges' questions is what metrics best assess the quality and reliability of AI-generated content. So the thing about our product is that we actually validate all the training data before we use it for training the AI model. So the user feedback when using the app is logged, and this data is validated with metrics which include correctness to make sure the AI's answers are accurate and that they are relevant and that they meet ethics, bias, and safety criteria, which make sure the answers aren't harmful. So the process is quite simple. We first use an automated evaluation system to run through the data first, and then SME comes in where they have to actually validate this, and only validated data is used for training a copy of the current AI model, so it makes sure we can revert to any past models if we have to, or if it's safer.
To prevent hallucination, we have built several guardrails into our framework. First, it uses retrieval augmented generation to ground every response in real heuristic and past test data. The model outputs only in fixed schema and follows deterministic decoding to avoid speculative text. It also evidence driven, which means if context is weak, it automatically returns insufficient evidence, request clarification. We then cross check results across historical mitigation, run contradiction checks, and include SME approval, which helps the model continuously learn what's effective and reliable.
To log the chain of reasoning and sources for audit, we've already included something into our user interface, which includes a submission history. This can also be exported into a PDF.